so the way this works with naming stuff is if we had a compound that kind of looked like this, CH4. So we might draw the structural formula kind of like this, C with 4 H's around it. Alright, and the way this works is meth tells us that we have one carbon in a row. And if we have a bunch of single bonds, we have what's known as an ane family of hydrocarbon. Alright? So hydrocarbons are things that have carbons and hydrogens, which CH4 is one of those. So this molecule right here is called methane, because it's one carbon long, and it's all made of single bonds. If we went to 2, and had something like this, C2H6, if we would draw this, we'd go carbon with a carbon, and carbons make 4 bonds, so around this carbon we can put 3 hydrogens, and around our left carbon we can put 3 hydrogens. And notice our formula is C2H6, and because we all have all hydrogens, and we have 2 carbons in a row, we would name this ethane. Next one, we can go to C3H8, and again we're just going to put 3 C's in a row to begin with, and then we're going to put 3 H's around, and this is going to be just kind of shorthand. In a while, I don't care if you write the H's or not, if you have little dashes going, I'm just going to assume there's an H at the end. So we'd have 1, 2, 3, 4, 5, 6, 7, 8 H's, and we have all single bonds. We have 3 carbons in a row, so because we have 3 carbons, it's a prop. Because it's all single bonds, it's propane. C4H10, and be something like this, C, 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 and that's 3, 4, 5, 6, 7, 8, 9, 10, and this 4 in a row, so it's prop, and it's all single bonds, so it's butane. Alright, what I want you to know here is methane is a gas, ethane is a gas, propane is a gas at room temperature, and then butane is a liquid. And then on down through here, these are all liquids as well. And if we go back to intermolecular forces, what happens? All these are non-polar compounds. All right, they're not polar. There's no hydrogen bonding because there's no N's, O's, or F's. But as we add more and more electrons, those electrons can be in different places at different times, so they're more likely to have stronger London forces. So as we go down, because intermolecular forces get stronger, we go from gases to liquids. Another one that you might be familiar with is right down here, octane. And whenever you fill your car with gasoline, it has an octane rating. And we'll learn a little bit more about isomers, but there's several isomers of octane, and the ratio of isomers is what your octane rating is whenever you fill your car. Right, the last thing, we're talking about anes here, or single bonds. They always have this relationship for their C's and their H's. So if we know the number of carbons, this is just some n, some number. H is always n plus 2. So if we had 20 carbons in a row, so we had something that was C20, I would not know how to name this, but I could very easily find that we're going to do 20 times, this is 2n plus 2. 20 times 2 is 40 plus 2 would be 42. And that makes sense because we have C, and with each C we have 2 hydrogens. So that is, I have 4 hydrogens right there, times 2 is 8, and we have a hydrogen on the right and a hydrogen on the left. So anyways, this formula will always give us our number of hydrogens if we know our number of carbons.